Hi all, myself Subitha Sudeer, Assistant Professor, Department of Space Science and Technology, St. Albert's College Autonomous. Today our topic is method of studying correlation. So we already discussed about that what we mean by correlation. So now we are going to explain about how we can measure correlation. So in one sentence we can say that the correlation, which means that if there is a change in one variable, whether there is any change in other variable, that particular change is measured by the tool correlation. So the next thing is how we can measure that particular correlation or that particular change between two variables. Usually we are using three methods for studying correlation. So first is the scatter diagram, second is the correlation graph, and third is the Cole-Pearson correlation coefficient. So the first thing is scatter diagram method. So like the name indicating, it is a diagrammatic method. Otherwise, it is a visual aid only for studying about the correlation. This particular method is showing just whether the two variables are correlated or not. We can add one more feature, that whether there is a following a positive correlation or a negative correlation. Since it is a diagrammatic method which does not measure any quantity of correlation, or which does not give the quantity of correlation between the two variables. So like the name indicating, we are using by some points, points of we are measuring actually the scatterness between the points. When we are plotting a particular variable or particular data in a particular graph, we will get so much of points in that particular graph. So by measuring the scatterness of that particular points, we are actually measuring the correlation between the variables. So we are going to explain about what we mean by that is what we are actually doing in the scatter diagram method. So this is a sample diagrams which of a scatter diagram method. Here you can see three different graphs in three different colors. So the first is which is showing up in a particular blue color. If we draw two variables or the data in a diagram, so we will be get as much of points whatever data we have in a particular graph like this. So this particular blue color dots showing, we can see that these particular dots are moving upward, otherwise showing an increment pattern in this particular graph paper. So if you plot a particular data in a graph paper, if it is showing an upward movement, otherwise increment pattern, we can come to a conclusion that there is a positive correlation between variables. If we have plot the points in a particular graph, so if we get a particular pattern like this, what it is actually this particular green points are showing, we can see that there is a downward movement between these particular points, this particular green points. So if we plot the data in a particular graph paper, and if it shows a downward movement, we can say that there is a negative correlation between the variables. Some data may not show any particular pattern like upward or downward, like the third graph is showing, which means that there is no correlation. That is, we can see that in this particular third graph, which does not show a particular pattern, there is no upward movement or there is no downward movement. So we cannot figure a particular pattern in this particular third graph. So we can say just the points are scattering in this particular graph paper. So we can say that there is no correlation between the variables. So only we get such an idea from scatter diagram, if they are correlated or not correlated. If it is correlated, but whether it is positively correlated or it is negatively correlated. So this is the data what we get from the scatter diagram method. Okay, so one more point we can add by using the scatter diagram method, whether there is a strong relation or a weak relation. So here I am plotted four different types of graphs. So when we come to the first part, here we can see that all the points are moving upward. So we can say that there is a positive correlation. But if you try to fit a straight line in between the particular points, in first graph, we can see that all the points are clustered or accumulated around this. Otherwise, all the points are basically on this particular red straight line, which means there is a strong positive correlation between the variables. So that is what I am written here, strong positive correlation. When we come to the second graph, the points are moving downward, and if we are trying to fit a straight line in between these particular points, we can see that all the points are clustered, almost all the points are clustered around this particular straight line. If almost all the points are clustered around this particular straight line, we can say that there is a strong correlation We have to say whether it is positive or negative according to the pattern. If it is moving upward, we can say that there is a positive strong correlation, and if it is moving downward, there is a negative strong correlation. In this particular third graph, here also we can say that it's an upward movement, otherwise an increment pattern existing between these particular points. But if we try to fit a straight line in between these particular points, we can see that only a very few points are clustered around this particular straight line, which means there is a weak positive correlation. If you want to say the strong correlation, which means almost all the points have to be lie on the line. If only a very few points are lie on the line, then we have to say that there is a weak correlation. Then look at the pattern. If it is moving upward, there is a weak positive correlation. If it is moved downward, there is a weak negative correlation. So that is actually how we are measuring correlation between the two variables from the scatter diagram. So these are showing some merits of the scatter diagram. Then the main demerit of scatter diagram is that it does not measuring the quantity of correlation, just showing whether it is positive, negative, strong, weak, if it is correlated, how much it is correlated. That quantity we will not be get from the scatter diagram. So that is the major demerit of a scatter diagram. Then the second tool or the second method used to study correlation is actually correlation graph. It is somewhat similar to scatter diagram, but here we are using, or here we are finding the correlation not based on the scatterness of the points. Here we are finding whether there is a correlation or not by using some straight lines. So this is actually the format of the correlation graph, because here we are plotting the two variables in a single graph paper, and by measuring the distance between, otherwise whether they are showing a convergence pattern or the divergence pattern, we are coming to a conclusion that whether there is a positive correlation or negative correlation. If it is showing a divergence pattern like the second diagram, here we are plotted the supply curve and the price curve. So we can say that the distance between the two straight lines are increasing, or which is showing a divergence patterns. If the graph is showing such a divergence pattern, then we can say that there is a negative correlation between the variables. If it is in the case of first diagram, so here we can see that here we plotted the variables weight and height, and they are keeping the same distance throughout the graph, which means that there is a positive correlation. So if they are keeping the same distance, otherwise if you are showing not otherwise, and if it is showing the same movement, then we can say that there is a positive correlation. If it is showing a divergence pattern and they are moving in the opposite direction, we can say that there is a negative correlation. This is how we are measuring or finding there is a correlation between two variables by using correlation graph. The third method is actually correlation coefficient. So among the three methods, correlation coefficient is actually the quantitative method used to measure the correlation. By means of quantitative method, we means that this particular third method is actually measuring whether there is a correlation or not. If it is found there is a correlation, which will give the quantity of the correlation between the two variables. So we are using three types of correlation coefficient methods. So the first thing is called Pearson's correlation coefficient method. Second one is Spearman's rank correlation method. Third one is concurrent deviation method. So the first two are have the major applications for finding the correlation coefficient between the two variables. So we are going to explain about the first two. So the first thing is called Pearson's correlation coefficient. So in short, we can say that called Pearson's correlation coefficient is a quantitative measure which find out whether there is a correlation between the two variables or not. Also, which give the quantity between the two variables. So since it is a quantitative method, here we are using a particular formula. So this is the formula for finding the Pearson correlation coefficient between two variables x and y. R is equal to sigma x minus x bar into y minus y bar divided by n into standard deviation of x into standard deviation of y. Here sigma x is standard deviation of x, sigma y is standard deviation of y, and n is the number of pairs of observation. And Pearson's we are using an abbreviation for Pearson correlation coefficient, that is actually small letter r. So the next thing is degree of correlation. So what actually the value of r. So what is the indications or what is the meaning of the values of r? So that is what we are explaining here. So we are actually dividing the correlation can be into three: perfect correlation, no correlation, and moderate correlation. So first thing we have to understood that the value of the correlation coefficient will range between -1 and +1. So if you have a data, we are finding the Colby-Pearson correlation value from that particular data. If you get the answer as -1 or +1, we can say that there is a perfect correlation. Whatever it is negative, if it is a negative value, we can say that there is a negative perfect correlation. That is, if the answer is -1, we can say that there is a negative perfect correlation. If the value is a +1, we can say that there is a positive perfect correlation. So this is what we mean by perfect correlation. So if we get the answer of correlation coefficient has to be 1, we can say that there is a perfect correlation between the variables. Then suppose you are given with a particular data, you use the particular formula for finding Colby-Pearson correlation coefficient, and you got the correlation coefficient value has to be 0. Then we can say that there is no correlation between the given data or the given variables. So there is a chance for recurring the values between 0 and 1. Otherwise -1 and 0. So when we obtain a particular value in between 0 and 1 as the value of the correlation coefficient, we can say that there is a moderate correlation between the two variables. So this is just an example showing how we are finding the Colby-Pearson correlation coefficient from two variables. Otherwise, two set of data, you are given with the two sets of values x and y. So x and y. So this is actually the calculation procedure. First, we have to apply the formula. So in this particular table, I find out all the data that is needed for applying particular formula. That is, we need the sum of x. So I find out the sum of x in the last column and the sum of y. So I find out the sum of y in the last column. And then we have to calculate x into y and have to take the sum of x into y. Then x square, have to take the sum of x square. Then y square, then take the sum of y square. So I calculated all the values here. Then substitute the values, apply all the values that we got from the table. So finally, we will get the value as 0.077. So the next thing is how we can interpret such a value. Whatever answer from me get the particular problem. So here we got the value as 0.077. So it is approximate to be 0. But also the sign of this particular answer is plus. So we can interpret the particular result as there is a positive and is approximate to be 0 but not 0. So we can say that there is a very low positive correlation between x and y or the given data. So this is how we are interpreting such a particular correlation coefficient answer of a particular correlation coefficient from a particular problem. Thank you.